Welcome to this explainer. Today, we're taking a pretty fascinating journey. We're going from the chaotic, Wild West days of amateur coding right into the structured, highly professional world of modern software engineering. If you've ever written code, you absolutely know that rush, that thrill of finally getting it to work, right? But what actually happens when we throw artificial intelligence into that mix? Let's dive right in and find out. Okay, so we've all heard the classic developer's battle cry. Well, it runs on my machine. It's kind of gritty, totally subjective, and honestly, it's completely unreliable in a professional setting. Now contrast that with the absolute gold standard. It works verifiably under defined conditions. Look at that difference. That is the pristine, highly valuable clarity of test-driven logic. Because professional code, it isn't just about syntax anymore. It's about actually proving that your software works exactly as intended, literally no matter where it runs. So here's our roadmap for today. We're going to start with more than just code, then explore AI as a brilliant test assistant. After that, we'll look at interfaces and system tests, uncover the danger of false security, and finally wrap up with moving from code to portfolio. All right, let's get into it. Section 1, more than just code, the perspective shift. Because today, just knowing the syntax of a programming language, that's really just the baseline. The real skill is something much, much deeper. And that skill is test-driven development, or TDD. Basically, this means formulating your expectations as executable tests before or at least very early on during your implementation. The absolutely crucial point here is that TDD uses rapid feedback to transform your, subjective hopes into objective, machine-readable facts. You're literally translating your requirements into a language that the computer can constantly verify for you. Now, this feedback loop works through a super simple three-step cycle. First up, the red test. You write a test for a feature that doesn't even exist yet, so naturally it's going to fail. And listen to me on this, a failing test is not a personal failure. It's actually expected, incredibly valuable information. It tells you exactly what needs to be built next. Then comes step 2, the glean test. Here, you write just enough code to make that test pass. And finally, step 3, refactoring. You improve the structure of your code and you do it with the absolute safety net of your green test, ensuring you didn't accidentally break anything along the way. Moving on to section 2. AI as a brilliant test assistant, accelerating the start. So, let's see how artificial intelligence actually supercharges this entire process. Think of AI as a kind of Trojan horse for quality. It's this lightning-fast assistant that helps us structure our testing. Let's take a password validator, for example. We need to account for normal cases, edge cases, and of course, error cases. Well, AI is phenomenally good at brainstorming these specific scenarios. If you tell an AI to generate edge cases for, say, an 8-character password limit, it instantly spits out exactly 8 characters, exactly 7, empty inputs, you name it. So instead of wasting your time trying to imagine every single way a user could potentially break your app, you just use AI to define those precise specifications. You're shifting your brainpower from just writing syntax to designing ironclad rules. All right, section 3, interfaces and system tests. Checking the big picture. Let's look at how all of this builds when we start scaling up the complexity. Because, sure, while AI is great at helping us with isolated chunks of code, real software, it's a massive, intricate web of interconnected systems. And as we scale, we really have to draw a clear distinction here. Unit tests, they check your isolated functions. But integration tests, they check the interactions and the contracts between multiple components. And here is a massive takeaway. Bugs absolutely love to hide in the chaotic transitions between components. I mean, a function might work perfectly on its own, but the second it tries to talk to a database or some external server, boom, everything crashes. Integration tests are what verify those crucial handshakes. Now, testing interconnected systems can get super messy if you're relying on live data. And that is exactly why we use mocks. Mocks are basically controlled simulations of a component that replace your real dependencies during a test. Imagine you want to test a payment system, right? You definitely don't want to accidentally charge real credit cards every single time you run a test. No way. So mocks, along with prepared data, which we call fixtures, they give you a pristine, completely controlled environment. They make sure your tests aren't getting tripped up by unpredictable external data, meaning your test only fails if your actual code is broken. To manage all these tests, we use a pipeline that acts like a giant automated factory. Build, test, deliver. You probably know this as continuous integration and continuous delivery, or CI/CD. It's an automated process that catches regression bugs. Those annoying old errors that accidentally creep back into your code? Yeah, those. And honestly, with AI helping us write code faster than ever before, we absolutely need this automated factory to run our tests after every single change. It enforces strict quality control continuously. But hey, before we get a little too comfortable with our lightning-fast AI tools and our fancy automated factories, I want you to stop for a second and really ask yourself, does this test actually check the requirement, or does it just mimic the code? Think about it. If an AI writes a flawed piece of code, and then you ask that exact same AI to write a test for it, the test is probably going to pass. But it's meaningless. It's literally just confirming the mistake. And that flips the script entirely. Which brings us to the core tension of our modern coding era. Section 4, the danger of false security, the limits of AI. This is the real battle right here. It's the incredibly fast but kind of blind AI versus the slower but absolutely critical human master. This tension creates what we call false security. It's that false impression of safety you get when tests are just covering weak, redundant, or straight-up incorrect expectations. You might look at your screen, see a sea of green passing tests generated by your AI assistant, and feel totally invincible. But we're warned about this. A green test from an AI? It might just be protecting a truly terrible implementation. It acts as a dangerous, professional-looking disguise for technical debt. So what's our absolute best defense against that false security? Well, it boils down to one simple rule. AI recognizes patterns, but it guarantees absolutely no factual truth. AI doesn't understand your business rules. It doesn't know your security constraints or what your users actually need. It's literally just guessing what comes next based on its training data. So the crucial takeaway here is that the responsibility for security and logic, that always remains with humans. You have to act as the ultimate quality filter. You have to evaluate if the real-world requirements are actually being met. All right, let's move into our final section, Section 5, From Code to Portfolio, Making Professionalism Visible. Let's talk about how this entirely new mindset directly impacts your career, your teamwork, and your overall learning journey. Look, in the age of AI, simply handing in a piece of code that seems to work is pretty amateurish. I mean, anyone can prompt an AI to spit out a basic script, right? A modern professional portfolio proves your competence by showing how you work. We're talking about including your tests for those tricky edge cases, showing your step-by-step refactoring, your critical reflection on the AI suggestions, plus your process documentation and your bug analysis. Documenting this whole verifiable process, that is exactly what sets a true engineer apart from someone who just copies and pastes AI prompts. Which brings us to the end of our explainer. But before you go, I want to leave you with one final provocative thought. Which test cases would you write first for your current project? Seriously, think about it. Think about the edge cases, the potential errors, the tricky interfaces. Don't just sit down and write code anymore. Define your expectations, use AI to brainstorm those boundaries, and build something that is verifiably secure. Thanks so much for joining me on this deep dive today, and I really hope this empowers you to take absolute control of your software engineering journey.